Welcome to another session of Training Tuesday from Dayton Superior. As always, all these presentations are intended for training purposes only. For technical applications or products mentioned within this training, please refer back to www.daytonsuperior.com for any technical assistance. Today, we are going to be talking about understanding concrete. Cement or concrete, uh, often used interchangeably. I will tell you that if you see a concrete truck running down the highway and you call it a cement truck, you will be automatically put on top of my list, just because it is a concrete truck. Cement is actually an ingredient within the concrete mix. Now, typically, concrete is made up of a base core of four separate products. You have cement, sand, water, and aggregate. And typically, if you look at your mix, the aggregate and the sand are held together by the cement. The cement is actually the glue of the concrete mix. The water actually is used to hydrate that cement to actually activate it so that it will become sticky and gooey and make up a nice fluid mix of concrete with the aggregate and sand. So, as I talked about, concrete is a mix of all four component pieces here. These are four typical components that you see here, and you will also have a portion here that is not included, which is uh, admixtures, which there's a variety of different admixtures, and we'll talk about them a little bit later. Uh, but this is the base core of concrete: aggregate, sand, cement, and water. I don't care how good cement you have or how good aggregate you have or sand you have, if you do not have good, clean water, that is the essential component within this product mix. The water actually hydrates the cement. So when by hydrating the cement, if it fully hydrates the cement, you're going to get full strength out of the requirements of what that cement was designed to hold and to actually do. So you need to have enough clean water for sufficient hydration. Now, when I say sufficient hydration, we don't want to get it too wet, because the wetter you make your mix, the weaker the concrete is. So you kind of thin it out. So basically, there is a point where you can go to where it's just right, or you can go just a little over and there'll be a little bit less strength. But if you go past that component, you will actually cause the concrete to actually lose strength. You'll end up increasing shrinkage cracks, voids, low strength, and generally poor quality concrete. So, concrete hydration and water cement. Now, typically, when you start mixing concrete and place it, it typically starts to generate a little bit of heat. The top of the concrete actually will start to get warm. That is the reaction between the cement and the water, that hydration process. The heat from that reaction is also referred to as heat of hydration. Um, Typically, it's something that we at Dayton Superior uh, don't pay a lot of attention to. This is typically a concrete contractor supplier issue with the ready mix companies. So the hydration of this product here, the cement reaction that occurs, is when water is added to cement. It actually activates the cement components, the limestone and so forth, within the cement to actually create a sticky component. Now, to achieve appropriate hydration, a good water cement ratio is required. Now, that ratio is typically put in place here so that you know how thick you want the concrete, how well you want it to flow, how fast you want it to set up, how slow you want it to set up. You have to understand concrete is a component piece. It's a lot like mixing bread dough. If you mix too much of one component in, you're going to get a different result. So concrete is typically prepared by mixing the cement, aggregate, water, and admixture together to make a fluid paste that typically can be used to form and fill the void forms without leaving any voids. So Portland cement is typically um, cement is produced uh, from clinker, is ground into a fine powder from. Now, clinker is a material that's made by burning together limestone and clay together at a very high temperature. It is then heated up. It creates this rough material here that typically then gets put into a tumbler and gets tumbler grinder, which will actually grind the material down as it's rotating in and around this drum. And the result product is actually cement that comes out of it. So what you are looking at is you have a couple of different types of cement here. Now, typically, most concrete that we see in the construction world is typically going to be a type 1 or a type 1L. Type 1 is a general purpose type cement. You see that uh, on average. 1L is general purpose. It's a blended cement. A lot of cement companies have gone to this because of the cost of the actual cement product has just skyrocketed over the last few years. So the cement industry has decided to try to uh, incorporate other products in here. That one of them would have been fly ash, etc. Those products that were blended in typically took away cement quantity from the mix and replaced it with either a fly ash. Now here with type 1L, they're actually increasing the amount of limestone within the cement mix. Um, or excuse me, within the concrete mix. And what happens here is it's a little bit different process now for hydration. The hydration process is a little bit varied and can vary even within its own subsector because of the quality of the limestone. We have a type 2, which basically controls sulfates used when heat buildup is a concern. Typically, you're going to see where this is going to be where you may see uh, hot weather concreting going into place here. Um, a lot of times you'll see a type 2 used in blast furnace areas, et cetera, high temperature areas within the system. Type 3 cement is in at high strength at an early state. You may see what they call high early concrete, where guys are having to, a lot of times you see like rapid repair of a roadway project that will use a high early concrete to achieve compression strength earlier so that they can open the road to traffic, etc. Type 4 is a moderate heat generated by hydration, so where you have to worry about standard uh, hydration process with the heat and worrying about it misshaping the beams, etc., or any other concrete forming accessories. And type 5 resists chemical attack by soil. Typically, you'll see that used as for underpinning projects, uh, piled piles, concrete caissons and piles being driven. We'll typically use like a type 5 cement for that type of concrete mix. Now, aggregates typically are defined in two different. We have a coarse aggregate, which is typically like a stone, 3/4 to 1 inch in size, diameter, and a fine aggregate, which is typically everything 3/8 of an inch and less, down to a particle of sand. So those are the two different types of aggregates that you typically have um, within the cement world. Admixtures, okay, um, are added to the Portland cement. Admixtures are like options in a car. Typically, you can add different items to the cement concrete mix, and what'll happen is you can actually come up with uh, a different concrete mix design completely as to what you initially started with, be a standard concrete. Most concrete actually had, almost all concrete has air entrainment in it. This is a product that actually helps the blending of the component pieces, the sand, cement, aggregate, and water. It actually helps that mixing process. We have a water reducing variable that you can add to it. This actually helps you get a more flowable concrete with less water. Retarding means that the concrete is going to have a little bit more time to work with it. It'll actually retard the set time within the concrete. And then obviously accelerating means it's going to speed it up. Uh, Workability agents and miscellaneous agents, which I like to call foo-foo dust. They can make everything happen from chemical resistance to high early strength to freeze-thaw resistance, etc. So those are all different component pieces that can be added to a concrete mix to actually enhance the workability and the performance of the concrete mix. Some of the terms that you're going to have to pay attention to or have to know is slump. Slump is the measurement of the mix's consistency or flowability. Typically, you're looking at something. Do you want something like a cookie dough, or do you want something like a pancake batter? The higher the slump, the wetter the concrete. A lot of times, the additional, if you have a lower slump, you typically will have a lower strength concrete. So, excuse me, a higher slump will actually indicate a lower strength concrete. So, uh, slump is actually a term used when describing or ordering concrete. Uh, Typically, you're going to see anything from a 4 to 6 inch concrete slump for concrete walls, and actually a 5 to 7 mix design slump for flat slabs. And that can vary based off of different components that are being put in the concrete mix itself. So slump basically for testing processes. You can see the cone that they actually have over on the side here. What they will do is they will flip that upside down, uh, start filling it up a third of the way, ram it, they vibrate, basically, and you simulate vibration with that steel rod, poking it down into the concrete 25 times, repeating that 2 more times, so a grand total of 3 times by the time they fill the cone all the way to the top. Then what they will do is then flip the cone over and remove it. They will then set it off to the side, and you can see how the concrete will settle just a little bit. So typically here, what you're looking at, you've got about a 3 inch slump material here in the top photograph. That would be good for basically a wall design. A lot of DOTs typically like anything from a 3 to 5 inch slump material. That material is workable, but relatively stiff so you can push it around fairly easy. The bottom picture here actually shows a higher slump concrete mix. So that you're talking is probably closer to an 8 or 9 inch slump. And that may be because of the chemical components within the concrete mix. You may want to mix like this for doing a slab that you have where you're going to have to you have the concrete mixed out so that you can ease and increase the flowability of this material for placement purposes. Compressive strength of concrete typically is the strength of the ability of concrete to withstand a squeezing force. Concrete is very good in compression, not so good in tension. So concrete can actually handle a lot of loads being pushed down on it. Uh, it is often referred to the compressive strength as equivalent to the maximum loads that can be carried in 1 square inch cross-sectional area expressed in pounds per square inch. So typically you're going to see concrete as a 3,000 pound mix or 5,000 pound mix. This is typically strength range from anything from 3 to 6,000 pounds. And yes, you can go higher and you can go lower. You can get strengths that are lower. Typically, you don't see a whole lot of strengths below 3,000 psi, primarily because that actually indicates that the concrete is susceptible to cracking and uh, shrinkage. Curing. Everything you do here, placing the concrete, putting it in place, is a result of a process here. And when you finish off the concrete, you have to ensure that you're not going to damage that surface of the concrete by one, either letting too much water evaporate off of the surface to actually um, basically suck the moisture out of the surface of the concrete, which will cause crazing cracks within the concrete mix. So you want to make sure that you apply a good curing compound to the product or a other curing method, which can be, there's a variety of them. You can use a plastic sheet wrap. You can use um, a synthetic cover. You can use a wet burlap. You can actually use just straight wet water if you wanted to pool the water on top of it. By heart, what this actually does is it slows down the hydration progress of the concrete, therefore enhancing the hydration process being a slower process, which actually helps in strength gain, durability, water tightness, wear resistance, freeze thaw, and stability. So it gives you a much better mix. So concrete curing is one of the most important things that you can actually do to ensure your concrete component mix. Does concrete crack? Yes. Uh, that is why we typically add steel reinforcement within this. The steel reinforcement, wire mesh, rebar, etc., typically are there designed to help hold the concrete together. Sometimes wire mesh and rebar and pre-stressing. Pre-stressing is a component fix where they're going to actually squeeze the concrete slab once it cures out a little bit to actually squeeze everything in to actually help increase the compressive strength of that concrete. And recently, we say recently, and when we talk recently within the concrete industry, you got to remember that the ancient Romans were developing concrete way back when. So and concrete typically hasn't changed a whole lot since then. What we are typically seeing today um, is new futuristic designs with admixtures, etc. But what we've also had to do is we change from adding steel to the concrete mix to where we've gone and replaced it with fibers, either synthetic or steel fibers, basically used to replace the steel within the concrete, reinforcement. Actually, it's going to what's going to hold the slab together. If it does crack, which concrete typically will, it will crack. Uh, the steel fibers and the synthetic fibers will actually hold that crack together, so it'll be tight. So, how do you actually finish concrete? Concrete is simple to finish. You actually place it using a wood or metal tool, level the concrete surface. Uh, and at this point here, you're typically going to vibrate also. Basically, this helps consolidate the material in and around the rebar, the wire mesh, and actually around the form so you don't have any honeycombs or actually void areas which can collect moisture. Typically, at that once you actually strike it off with the float, you wait for the uh, water. What'll happen is water will start, the hydration process will start. Water will start to rise to the top. You'll get a nice sheen to the top of the concrete slab, a wet look to it. Once that wet look comes off of it, it leaves the surface. You get on it, you finish it up with a float, and then you can edge and groove to produce your rounded edges and control joints at that point. You want to smooth it all out with that. That's when you're going to steel trowel it. And then you're also going to texture it after that, usually with a broom, non-slip surface. If it's a bridge or highway construction, they may end up using either a wet burlap drag or a AstroTurf drag to actually create that roughened surface of the bridge deck to actually increase traction. Then you will have to cure the concrete. And that is how you actually handle concrete. If you have any questions, please refer to training@DaytonSuperior.com. If you have any technical questions, please check the DaytonSuperior.com website. And if you don't find the answer listed there, send a question on into training@DaytonSuperior.com. Thank you and have a good day.